Welcome back to our second week of using Excel for applied public health stat analysis. And we're going to now finally get to using the t-test. So the previous videos focused on the assumptions. Now we know what our assumptions are, whether we met them or not. And then in this case, we'll just choose to push forward on using the t-test. So are the t-test assumptions met? Well, I don't think that they were because the normality and the skewness and kurtosis, all that stuff was all out of whack. Now, were the data collected for the purpose of being compared? No, they were not. They weren't collected for the purpose of being compared in the sense of a paired t-test. So I'll show you an example of that here in a second. Are the data to be analyzed comparing two groups based on the mean of their aggregate? And that's the truth, yes. Are data to be compared against a known population mean? No, not yet. We haven't tried to do that. We can do that in another video. So this last one is called the one sample t-test. This is the typical kind of t-test. This is the paired t-test. So you could also call it the unpaired t-test. A paired t-test is done when you intentionally are trying to compare whether or not things collected at the specific point in time around a sample are related. And you see this a lot with laboratory measures. Correlation analysis will lie to the same thing, but in the event that you were interested in the mean around this group changing, so here we've got two different methods, the E. coli testing method here. Here's another one using this testing method. And if you were interested in seeing are the methods doing the same thing on each test, where for this water sample you tested it using this and you took the water sample and tested it using this. Then you collected a second water sample from a different place, tested it using this one, and then tested it using that one, and then you recorded your results there. So when you're doing repeated measures around a particular sample, or you're using two different competing methodologies around a sample and you want to see if the methods are the same, we would call that a paired test. Here, we didn't do that. Here, the data were collected over 2014 and 2018 in general education classes from a random assembly of whoever was in the gen ed classes. There was no paired analysis. So we're looking at the overall ages in this case of the ever e-cigarette users and the never e-cigarette users. If we were to do a paired t-test, it's pretty simple. You would just highlight your columns using the paired t-test option in Excel. If you don't enter anything in there, it just assumes 0. If you click labels, that will account for the labeling at the top, and then you hit OK. It will then present a new Excel spreadsheet that gives you all of this information. And you can see down here we've got one tail, critical value, p-value. So here we got the correlation between the two of them, but we also got the two-tail p-value. And the two-tail p-value is 0.68. So when you see 0.68, that is greater than 0.05. So high p-values mean no significant difference. And if you were trying to show that these two methods were doing the same thing, then that's the result that you would want. You would want the high p-value to say, yes, the methods are producing the same mean value, assuming that they met the same assumptions that we expect for all t-tests, normal distribution, and so forth. Now, that's the example of the paired t-test. An unpaired example, like what we're doing for this class, you remember previously we had unequal variance between our two samples. We also didn't have normality being met, but we'll go ahead and push the t-test through anyway. So we get the t-test. We're going to do the two sample assuming unequal variance, and we would then have to highlight those columns. So again, what are we trying to do here? What's the purpose? Well, we're wanting to know, is there a difference in the mean age of the ever e-cigarette users and the never e-cigarette users in this population of EKU general education class users. So we know that also 2014 and 2018 are combined, so that's an additional stratification that could be done. But when we look at the age group for the, I believe the ever, or maybe this is the never, I'll have to double check that here in a second. When we compare these two groups, what do we see? We see a p-value down here, a two-tail, two-sample t-test p-value of 0.49. You also see one tail up there, which is always going to be half of the p-value of this one. But this is the most common one. And the p-value, if you want to expand it out so you can read what it says, p-value of the t-test, two tails, 0.49. So, what does that tell you? Is there a significant difference between 20.1 years of age and 19.96-ish years of age? Is that difference significant or not? Well, there's your p-value, 0.49, so you should know that. So usually the two-tailed tests are used, and if there was a p-value less than 0.05, you'd say that there was a significant difference between the two groups. Here we have a p-value of 0.49. So since 0.49 is greater than or equal to 0.05, which is clearly way above, then we have insufficient evidence to conclude a significant difference in the variable of interest, or age, exists between these two groups. So there's no difference between these two ages. So it doesn't matter which one was the ever and which one was the never group. We don't need to worry about that. There was no difference. If one-tailed tests are used and you felt like one group would be higher than the other, if you felt like the younger population would be in the ever e-cigarette user group, then you would need to see the ever e-cigarette group being a lower age, say it's that one, and you would also, I believe it's actually this one though, but I'd have to double check. Well, let's go ahead and run that. So we'll pull up the Excel sheet here. So here's our yellow here. In yellow, we've got the ever e-cigarette users. So they're the let's see, where are we at? Ever, it's the AR group. So that's the AR is the ever. So AH is the ever. So tools, data analysis. So AH is the culprit there for ever e-cigarette users. And it doesn't tell us, but we know that AH is this one right here. It's the second column. AH is that one. So it is younger, and if you went into this with the hypothesis that they would be younger, rather than using this p-value, you would use the one-tail p-value. You could also use this two-tailed p-value, and instead of using 0.05 as your cut point, you could use 0.025 and then just look to see is it younger or not. So that's easy enough. All right, hopefully this has been simple. I'm going to go back to the PowerPoint here for you, and I think that wrapped up everything on the t-testing for now. So if you have any questions, let me know. You got my email address there. You can also always call me as needed. And I will stop this video and we'll go to the next one here on using like categorical variables and chi-square type testing here momentarily.